The ROI of the developer experience. That's the next movie, or documentary rather. Awesome. Zach, I know you have lots of experience and demos related to some of this work. And so I'm wondering if you have anything available to show us, to maybe talk through how we might do some of this in real life.
Yeah, I can share my screen and we can do a little bit of a live demo. Say the prayers or chants to make live demos go good. However,
The real test.
The demo
right.
gods smile upon you, hopefully.
All right. Okay. Let me make this bigger. So let's put ourselves in the shoes of a developer working on a new project. So I have this empty Python file here called MNIST. For those that don't know, MNIST is a machine learning data set that is a bunch of pictures of handwritten digits and like numerical digits 0 through 9. And this is sort of like the hello world of machine learning, where hello world is you write a program that prints out hello world. It's usually the first thing that you do when you're learning, for the first time or a new language, just to get that hello world test. So I like to think of MNIST as this sort of hello world of machine learning. And we're actually going to use AI to completely build this a training loop to train a model to learn how to recognize these characters. And we're going to train it live, and it should be very quick. So training loops can be very long on large models, but this should only take a few seconds to train a model. So I have GitHub Copilot set up. So this is something that I love for the developer experience. There's a lot of people using another editor these days called Cursor, but I'm still stuck with VS Code. I like it. And Copilot has been progressing really well. So let's say I'm going to set up this new project. I can just do Command I and say, write a simple script, simple training and test script for MNIST in PyTorch. So PyTorch is a machine learning library that's commonly used. Use a convolutional neural net. This is a type of architecture of neural networks for machine learning. Use a convolutional neural net and the Atom optimizer. Atom and optimizers are sort of the thing that actually updates your neural networks during training. So this is just specifying what I want. I want a training script. I want the test script to sort of validate things. We want it to run on the MNIST dataset, which I already have downloaded, using PyTorch. I've specified what type of architecture I want to use, the convolutional neural network, and what specific optimizer I want to use. We press enter. Look at that. That looks pretty good. So this is our model architecture right here. I'm just going to quickly go through, make sure that everything's good before we move ahead. I probably would have picked a different loss, but that's all right.
While Zach is doing that, I'll just call out here that I think, there are questions or anxiety about whether AI is going to take all of our jobs as developers. And Zach is showing in both the pre-step, the prompt, and the output why we're still going to have jobs, which is you have to know the right question to ask, and you have to be able to verify the output afterwards. And whether you are a chef prompting for a recipe or developer prompting for code, like you have to be the expert in what is going to come out of it so that you know that you're not about to poison a room full of people or spend $2 million training something that doesn't work.
So this looks pretty good. And just to verify, we're going to be able to run this .py. So this is going to run an actual training loop on this model to see if we can actually recognize these digits. Ooh. I'm going to actually, I'll let this run and just sort of simplify the process here by removing some of these dropouts that it's complaining about. We don't really need them. I don't need to go into details of it right now. You probably do want them in a real model, but we don't need them here. Okay, that looks pretty good. So this ran. It trained a model. We got a 99% accuracy on recognizing digits. But now let's say that I was just given this already, like this code. And what I really want to do is, so I specified that we were going to use the Atom optimizer for this. What I would like to possibly try multiple different optimizers to see what works best for this sort of problem. So instead of just prompting the whole code gen, we can actually use this sort of edit with Copilot feature to sort of interact with our code base and have it edit inline. So let's say I would like to run the test and, or let's just, the train and test loop with a few different optimizers to test their effect on the model. Perhaps we can start with Atom, which is the one that we're already using, stochastic gradient descent, which is sort of how this, it's sort of like the oldest optimizer in a certain way, and just another one, let's say RMS prop, something like that. So it's going to think and generate. And this is a way that if you already know what you want to do, you can very quickly get the code spit out for it. And you can even see what, how it changed the code. So it removed all this section and added this section. So now we can see that it actually has this little dictionary of optimizers that we're going to use, both Atom, stochastic gradient descent, and RMS prop. It's added a loop around the main code here so that it actually instantiates this optimizer here based on each of them. So let's just do a quick look through, make sure nothing else got wild. Looks good. So let's just click accept. Oops. And save this. And we can run this again now. So now it's doing a test training loop with the Atom optimizer. So it's going to run through 5 epochs. And epoch is basically just one whole pass through the data set. So we're running through the entire data set 5 times for each of these. So we should see a pretty similar result for this one. We got 98.89. It's within, the standard deviance of what we would probably expect. There's sort of a stochasticity, a randomness with this, so they're not going to be the exact same every time. So now it's running with stochastic gradient descent. You can see this one's a lot lower, and that's to be expected. It's not as an advanced optimizer, so that's something we would expect. And we'll see with RMS prop as well. You see that was pretty good too, 98.92%, which is about what we expected. So what we were able to do is take a code base that was already existing and make some modifications in line, with a carefully crafted prompt of knowing what exactly we want to do. But maybe we don't know exactly where it needs to go, but it will show us where, what it removed and what it put in, and then you can review. And then we can test. So now we just upgraded this simple script to actually testing several different optimizers on this same model. Could pause there. I got one more little thing I would like to do, but I don't know if there's anything we want to chat about there.
Well, maybe run through your next activity just so we can have the complete set, and then we can dig into some questions.
So this is, having it print out is great, but it's okay. It's not great. It's just, saying, yeah, the accuracy is this. We ran through all the epochs. We use this optimizer, blah, blah, blah. But we're not really able to compare too much data except for the last validation. And also, this is a model that's looking at images and predicting a number from it. We're not seeing anything. We can't see the images, that sort of stuff. So what I would really like to do is have it plot out, charts during the training. How good is it doing? And then also see the pictures and what labels the model gave to those pictures. But maybe I'm not familiar with this code base, and I'm a little nervous about that, or just want to be more efficient with how I'm spending my time. So we could use these same tools to get that accomplished.
I love that application piece. And speaking of the developer experience, what is it that you might be feeling or sensing as you're approaching this? There's actually a comment in the chat from Thomas Cole, I believe, TJ. As a developer, I've tried a few LLM tools for coding and found almost all of them actively get in my way when it comes to programming and slow me down. What sort of suggestions do you have for exploring these sort of tools? Or what sort of things should I look into to adjust my experience with them?
So first off is using a really good model, I think is a good one. I don't know what kind of model they're using. In this case, I'm using O1 Mini for this, which I find to be pretty good at these sort of things. Another model like Claude Sonnet or just O1 in general are quite good at coding. But they really need the context. Like they need good context. You need to provide um, sort of intelligent prompts, like very deliberate prompts, like that you know what you want, how it should look, that sort of thing. Um, and there's one way before these tools started getting integrated into these developer environments. I'm sure a lot of us would take a snippet of our code, go to like Chat GPT, post it, and then go back and forth. I don't find that very effective at all. And sometimes it can be to tell you things about code. Um, but I just don't find it very useful. In these sorts of cases where we have it integrated into the development environment and it can edit the code in line and tell you what it did, you can much more easily do a back and forth with it if you need, or just more quickly review what has been changed and just click accept. There is sort of an art to it instead of a science, of just kind of getting a feel of how to use these tools. Um, so I would say, just as a suggestion, try maybe either this sort of setup or the cursor editor, um, and kind of just start to get a feel for inline code editing and code suggestions. You don't have to do big things, but you know maybe there's just like a test file. Like we write a lot of tests for code to validate it that it works, and maybe you know exactly what all the tests are going to look like, but it's just going to be a slog writing all of them. It's going to take a long time because there's just so many tests, but they're so simple. You still have to write the code for it. Maybe just start there to generate your test files and then quickly review and edit them a little bit. Could save you a lot of time that that point, especially like in my experience, sometimes the test files end up being a lot longer than the actual file they're testing. It can just be very menial and stuff. Start with the menial stuff and then kind of build your way up to building the main application with it. So let's start prompting this for my next step. So I want to actually get a visualization of what these are doing, what's happening during training, and be able to compare these different versions of this training loop a bit better. And I want to see the pictures and what the model is actually predicting. So I would like to log batch loss to TensorBoard during training. I would also like to see images from the test set in a grid with their predicted labels in TensorBoard as well. Perhaps we can use matplotlib and subplots for that. Even get a little specific, like maybe I know exactly what I want to do here, just to say like I want to use matplotlib, and save that to the TensorBoard. TensorBoard's a nice utility for machine learning to log all these sorts of things, but it could be anything, whatever technologies you want to use for this sort of thing. Even just saving pictures and saving them to disk and being able to look it up. So let's run that and see what it will give me. Let it do its edits. And you can actually see it's doing it sort of in real time, editing. All right. So let's review. That looks pretty good, but there's actually, I do want to make some changes to perhaps make this a little bit better. Let's grab this, put this in here. Um, We actually want to say this is dot dash runs slash op name. Put this in the loop as well. And double check the image stuff. All right, that looks okay. And just put that. Actually, nope, we don't want that. There we go. Okay, so I believe this should be good now. So if we run this now again, take just a few moments to run through our training loop again. I'll close this window so we have a little bit more space for the next part. Something broke here. The demo gods were not happy with me today, apparently. Well, we can fix that in a second.
While you're
ahead.
fixing that, I think it was a really interesting, while you were the question from TJ was really interesting, and it reminded me of an internal project that another engineer worked on here, which is effectively, we've been building some plugins. I think if you check out Codengscape on Figma, you'll see that we've got a couple of Figma plugins up that use Gen AI, and we also have a VS Code plugin that we use internally, and we'll probably publish as well. And they're small, simple things, but they help with this kind of modernization approach we talked about before and developer experience. But the plugin we have, one of the functions that it does in VS Code is you can generate comments for a file, and it will create a copy of the file with the comments in there, which is pretty useful. But we took it a step further, and you can kind of specify the verbosity of how eloquent you want the comments to be, whether you want it to be at the line level, which if you're trying to understand like a pretty complicated, maybe piece of legacy software would be helpful, or if you are just trying to clean things up for whoever's coming along after you, like you can also specify file level, module level, function level, etc. And so these are good examples of how we think about using these tools. We're not just plugging code into OpenAI or Copilot. We're actually thinking about like, hey, how do we build something? And those Figma plugins we can link to them in the show notes because we're a podcast. Include like, hey, like take a Figma file and turn it into code, which is something that I think there's a lot of tools out there, but we also are able to generate the alt text for accessibility for images and things, and insert that right into the Figma as well, so that when when somebody picks an image and adds it to a Figma, it streamlines that accessibility pipeline.
For sure. So I did a fix, but it looked like it actually was just printing out the wrong numbers and actually worked. So now we can actually see some of the images from this. So this is what the data set looks like. And these are the predictions from the model that we just trained on each of these optimizers. So we could see it correctly predicted 7, 2, 1, and so on and so forth. And it looks like they all did a pretty good job despite their, subtle differences. And perhaps just as the last one, I did run another query to update it. So let's just see if it actually fixed anything. But that's basically, this is a large part of my workflows, a large part of workflows for other developers in sort of their modernization efforts, and just improving how you're spending your time, more bang for the buck with a lot of these things. Yeah, it seemed to fix it. So we can see that we're getting the accuracy 98.89%.
all done live in a demo in less than 30 minutes. I think that's pretty compelling.
And we used AI to make AI as well, which is kind of funny.
So meta. So
All
meta.
right, don't forget to submit your pull request before the end of the day, Zach.
All right, I'll work on that, Jimmy.
Cool. Lauren, I think you had a couple of questions as well.
I did.
that
I
we
was
wanted to get into.
wondering, what about, for a client that's a little, I think there's still some hesitation around privacy and data. And so when a client or an organization might be concerned about their code being exposed, in some of these tools, what's both of your informed response to what about data privacy and what about my code privacy?
Yeah, those are great questions and valid concerns. And I think it comes down to understanding two things, like if you're an organization and you have a code base effectively, understanding what portion of that is probably commodity in the sense that it might be open source code already or something that anybody could write. And what part of that code base are trade secrets that you would not want shared in any way? The trade secret portion is probably less than most people think, but understanding like how to kind of separate those out is difficult. So um, the best thing to do if you have concerns about that as an organization, like what we will do is help you evaluate the licenses for the various models. Zachary already talked about the importance of picking the right model, but you can for some of the large language model providers, there's licenses that effectively promise, although I don't know if they guarantee, promise that your data doesn't leave the container that you're effectively running it in. You can do that on Azure and AWS. You could also run your own open source model as well, and that is another way that you can protect your privacy. And some of these developer tools that we've been looking at can hook up to those models as well.
Yeah, pretty much nail on the head, or hammer on the nail, however that goes. Yeah, there's even using, I haven't looked too in depth on the licensing, like on specifically on ChatGPT Enterprise, but as far as I understand, they do data security on that where they don't train on it, it's not sold, it's not visible to their developers or other folks in house. But that's something you would want to consider to look into to make sure that the details really match what you need. But yeah, local models that you can set up yourself through the open source, that community is exploding with some seriously impressive models. Yeah, or just running a managed service on the cloud.